in this video we're going to start Chapter 8, Additional Topics in Trig, and in this course we're only going to do the first two sections. We'll start today 8.1, the law of sines. Next section will be 8.2, the law of cosines, and then we will be done with Chapter 8, and actually we'll be done with trigonometry altogether for this course. And the law of sines is a good place to start. Not overly difficult and very useful. In this section, what are we going to cover? We're going to use the law of sines to solve oblique triangles. AAS and ASA, if you remember from geometry, that would be angle, angle, side, and angle, side, angle. And we're going to use the law of sines to solve oblique triangles. And this was the case that did not work in geometry. The side-side angle case. You know, that was not one of our geometry theorems because there sometimes is more than one solution. And in this class and in trig, we're going to dig a little deeper into that, and we'll solve it for both possible solutions. We also have a new way to find the area of oblique triangles. Usually we want areas 1/2 the base times the height. And in an oblique triangle, we would have to determine what that height was. With the trick in the that we'll see here in 8.1, using a little trig, we don't need the height of the triangle. We just need a few other pieces of information, and we can find the area of that triangle. Now, in Chapter 6, we studied techniques to solve right triangles. In this section and the next, we will be solving oblique triangles, or triangles that do not have right angles. As standard notation, the angles of our triangles will be labeled capital A, capital B, capital C, and the side opposite these angles are labeled A, B, and C lowercase. So here is angle A, straight across from angle A is side A. Here is angle B, straight across from angle B is side B, and the same for C. So to solve an oblique triangle, we need to know the measure of at least one side. We gotta have a side, and then we need two other measures of the triangle. We could have either the other two sides, or we could have two of the angles, or we could have one of each, one angle and one side. And this breaks down into the following four cases. Case 1, two angles and a side, and that could be angle, angle, side, or angle, side, angle. Or we might have two sides and the angle opposite one of them. Side-side angle. Again, that's the one that did not work in geometry, but in this class we'll solve for both possible solutions. These two are solvable with the law of sines. In the next section, 8.2, we'll cover the law of cosines, which covers 3 and 4 here in these cases. The third one is three sides, side, 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 or two sides and the included angle, side, angle, side. And here in all its glory is the law of sines. Very easy to remember. If ABC is a triangle with the sides A, B, and C, then side A over the sine of angle A is exactly equal to side B over the sine of angle B, and that is also exactly equal to side C over the sine of angle C. And this applies to triangles that are both acute and obtuse. And if you prefer the reciprocal form, we can just flip all three of these over. Sine of A over A is equal to sine of B over B is equal to sine of C over C. And here in example 1, we have two angles and a side. And we are in the format of angle, angle, side, angle, angle, side. We have angle B, the next angle over is C, and then connected to that is side B, angle, angle, side. We know those three pieces of information, and we are asked to find all remaining sides and angles. Well, let's see, the easiest place to start is going to be to find angle A. If we take 180 degrees in a whole triangle, and we subtract the two angles we have, minus 102 and minus 29, we figure out that angle A is equal to 49 degrees. So angle A is 49. Oops. And just because it's new, I'm going to write out the law of sines. A over the sine of A is equal to B over the sine of B is equal to C over the sine of angle C. And let's plug in what they've given us. Do we have A? No, we don't know what A is. We'll be solving for that. We do know angle A is 49 degrees though. So down here we put the sine of 49. And that's exactly equal to side B, which they did give us, 28 feet, over the sine of angle B, and B was 29 degrees. And that is also equal to C, which we do not know, over the sine of angle C, 102 degrees. So now we're all set up. What did I do? There we go. We've set up our law of sines, and now we're just going to do a little cross multiplying to solve for the missing pieces. So first, I'm just going to concentrate on these two here on the left. We have a proportion, one fraction set equal to another fraction, and of course we solve this by cross multiplying. So we're going to have A times the sine of 29 is equal to 28 times the sine of 49. And we're solving for A, so we're going to divide both sides by the sine of 29. So our numerator is 28 times the sine of 49 degrees, and that's divided by the sine of 29. So we punch this into the calculator. Be careful with the button pushing. I would personally start this one off by writing or putting in the calculator 49, and then taking the sine of that, and then times 28, and then I want to hit equals because my numerator is done. And then I want to divide by 29 sine, and then hit the equal sign again, and we figure out that A is approximately 43.59. Let's take these to two decimal places. 43.59 feet. We do have our units as feet. And if we back up and look at the proportion where we cross multiplied and set it up, sort of a shortcut way to do this. You could write it out like this and divide both sides by 29 if you want. But after you do a good number of these, you start to pick up and see that if I am solving for this A, it's going to be equal to a fraction. The numerator of that fraction is the other diagonal. It's 28 times the sine of 49. And then I'm going to divide by what is across from what I'm trying to solve for. Across from my A is sine of 29. That is what I'm dividing by. So that's just a little shortcut method, and let's try it here because we still have to solve for C. So I'm going to take this and slide it over now, and now I'm just going to concentrate on this proportion. These two fractions set equal. And let's try my little shortcut. We are solving for C. So C is equal to the other diagonal multiplied. Here it's going to be 28 times the sine of 102. And we're going to divide that by what's across from C, the sine of 29. And if we punch that into our calculators correctly, we get C is approximately 56.5. And let's see here, we have a little study tip. And it says, when solving triangles, a careful sketch is useful as a quick test for the feasibility of an answer. Remember, the longest side of a triangle lies opposite the largest angle, and the shortest side lies opposite the smallest of the angles. So after you solve a problem, if you have a little sketch, make sure the biggest side is across from the biggest angle. The smallest side is across from the smallest angle. It might not catch every mistake, but it will catch some of them, most of them. And let's see what we got here in example 2. A pole tilts toward the sun at an 8-degree angle from vertical. 8 degrees from vertical. It casts a 22-foot shadow. The angle of elevation from the tip of the shadow, down here, to the top of the pole is 43-degree angle. How tall is the pole? Let's see, we don't need to solve for everything that's missing. We only need to solve for the height of the pole. And let's sometimes these book pictures are a little cluttered. I'm just going to do a stripped down version of it. Here's a triangle. We got angle A, B, C. We know that from the shadow of this is 22 feet. We were told this angle is 43 degrees. So this is side A, this is side B. What is angle B? They told us it's an 8-degree angle from vertical. Here is our right angle. If the pole was vertical, it'd be standing straight up, and that would be a 90-degree angle. But the pole is tilted 8 degrees away. So this isn't a 90-degree angle, it's a 98-degree angle. So we do have two of the angles. If we want to find the missing one, 180 minus the two angles that we have, and we're going to see angle C is 39 degrees. So let's start to set up our proportion. We could set up the entire thing, all three of our fractions, but here we don't need to solve for everything. So start with what you want to solve for. A is the length of the telephone pole. Across from it is its angle. So we're going to start by A over the sine of 43. And we want to set that equal to, the next fraction should have both the numerator and denominator. Known values, not variables. Well, let's see. We don't know B, and we know the angle across from it, so we're not going to use that. We're going to have to use the last angle inside. C and angle C. C is 22 feet. Angle C is 39 degrees, the sine of 39. So here we would cross multiply. These two multiplied together are equal to A times the sine of 39, and we divide by the sine of 39. Or you can just say A, what we want to find, is equal to the other diagonal, 22 times the sine of 43, divided by the sine of 39. And we punch that into our calculator, being careful to make sure we hit all the buttons in the right order, and we get A as approximately 23.8 feet. Now we're on to some practice problems in the team huddle. In the first one, use the law of sines to solve the triangle. Round to 2 decimal places. Solve for all missing things. First you'll find angle A that's missing, and then you'll solve for side A and sine C, or side C. In number 45, it's a lot like the last example. Because of prevailing winds, a tree grew so that it's leaning 7 degrees from vertical. At a point 25 meters from the tree, the angle of elevation to the top is 30. Find the height of the tree. This problem, when you are doing the homework assignment, number 35 is identical to this, but I just changed the numbers. So this would be a good problem to model homework problem 39. So pause the video, try the problems, turn it back on, see how you did. So let's see here in number 5. We're going to use the law of sines. A over the sine of A is equal to B over the sine of B is equal to C over the sine of C. First order of business, find missing angle A. Subtract the other two from 180 and you get 30 degrees. So there are all of our denominators. A is 30, sine of 30. B is 45, sine of 45. And C is 105, sine of 105. Our numerators are the sides, and the only one we have is B, which is 20. So we're missing A, we're missing C, a lot like the example. Let's focus in here first. Cross multiply and solve for A. So we're going to have, when it's all said and done, A is equal to 20 times the sine of 30 divided by sine of 45. If your calculator is giving you bad answers, the first thing I check is the mode. Make sure you are in degree mode and not radian mode. So when we punch that in the calculator, we're going to get A is approximately 14.14. And they didn't give us any kind of units, feet or miles or whatever, so it's just 14.4. And now we want to look at the other proportion. And we're going to cross multiply here to solve for C. C is equal to 20 times the sine of 105 divided by the sine of 45. And we punch that into the calculator and get C as approximately 27.32. So here in 45, a tree is growing so that it's leaning 7 degrees from vertical. Vertical would be 90 degrees, so this is a little more than 90 degrees. It's 97. A point 25 meters from the tree, so we're 25 meters from the away from the tree. At this point, we have an angle of elevation of 30 degrees. So, I'm used to the ABCs, and they have this as an H. I'm just going to rename my triangle. And you can name any vertex you want, A, B, and C. It doesn't matter. I'm just going to go counterclockwise or clockwise here. As long as you put side A across from angle A, you're fine. Side B across from angle B, side C across from angle C. And we just found here angle B is 97 degrees. Side C is 25, is it feet, meters? Meters. So now we're in meters, 25 meters. Angle A is 30. So what we want to find is the height of the tree here, or in my diagram, it's going to be side A. Side A is what we want to find. We don't need B at all. So we want to find A. So A over the sine of A, or the sine of 30, is equal to another fraction. And that fraction we need both the numerator and denominator. We don't have B, but we have angle B. We're not going to need those. What we're going to need is angle C and side C. We have side C. That's 25 meters. We need angle C, and that's easy enough to find. 180 minus the two angles that we were given is going to show us that angle C is 53 degrees. So angle C is 53. Sine of 53. And then we cross multiply. A times the sine of 53 is equal to the other diagonal, 25 times the sine of 30. And then we divide by the sine of 53. Divide by sine 53. You punch the buttons in the calculator, and you will find A, the height of the tree, is approximately 15.65 meters. So there's an introduction to the law of sines. The homework problems for tonight, 2 to 5 all. I believe the first couple problems they give you the picture and they want you to find the missing sides. In maybe numbers 4 and 5, they just give you a description. Angle A is so many degrees. Angle B is so many degrees. This side is so many whatever, feet. Draw a little picture. The picture really helps it all come together. Set up the law of sines and solve. Again, problem 35 is almost identical to this 45 huddle problem. The numbers are just different. Use number 45 to model number 35.